Now where data will be connected? Now data will be connected here at the serial input. So let me tell you, this is data input serially, which will be shifted towards right. Okay, now how this data will be shifted to right, let us see. So as soon as the first clock cycle occurs, data is fed into the AND 1, which is activated through the M bar, which is 1. So here it is 1 with data, let us say suppose first bit is 1, so this data will be loaded here in the A flip-flop. For the next clock cycle, next bit will be loaded to A, and whatever the data previously at A was connected to 3. At the same time, whatever the data was present in the B is connected to C, and C to D, and here you can take D as the serial output. So this is nothing but the shift right operation. Okay, for M is equal to 0. Now the last term is remaining, that is nothing but the shift left operation. Let us see how shift left is working in the universal shift register. So for that, let me clean out the slide. Okay, now here for left shift left operation, so let me modify this. Shift left operation is going on now. Now what we do, once again we'll connect M equal to 1, which will be corresponding to shift left. Okay, now for shift left, M is equal to 1, so M connected to 1, here it will be 0 is connected to 1 once again, and 0 is connected to AND gate 9, so clock 1 will be disabled since the AND gate 9 is disabled by the M bar. Also along with that, it is connected to AND gate 1, that will be discarded because it is connected to 0 here. Similarly, gate number 3 or the AND gate 3 or 5 and 7, so whatever the serial input was there, which will be discarded or the don't care condition. Now since we are operating the shift left, so data will be input from the D pin. Okay, so here it will be the data input serial manner. Okay, so it is the serial data input. Now all the connections are set, serial data input is connected to D. Now what connections we need to make? From the data should be moved from D to C, C to B and B to A. Okay, and it will be taken out from the QA part. So there are some modifications. Let us see. For the first falling clock, what will happen? Data is inputted to D. Now this D should be connected to C. The data for the next clock cycle, it should be moved to C. First of all, data will be entered to D flip-flop through the 8th AND gate. Okay, afterward that, for the second clock cycle, it will give out the data at QD. So let me connect the QD to C pin. Now if QD is connected to C pin, once again gate number 6 and gate 6 is activated. So whatever the data is coming from QD, which will be entered to C. Okay, afterwards from C, then I'll take the QC part. Okay, and QC will be connected to B. Through B it will again enter the data from C to B. Okay, and QB part, QB will be again connected to A, and from this QA data will be serially out, serial output data. Okay, so this is how the universal shift register works. Okay, for this is the block diagram or the internal structure of an universal shift register IC, particularly for 4-bit. That IC is 7495. Okay, so IC 7495 is there, which is called as universal shift register IC. Now for this IC, what are the pinouts, we will see in the next session of the universal shift register. Currently we have seen the internal structure of the IC 7495. Thank you for watching in 5 minutes, and for more videos stay tuned.